What's up, class? In this video we're reviewing our formulas for perimeter and area. First problem, find the perimeter. Okay, so marking up the diagram, first thing I notice is that right here I have a 3, 4, 5 triangle. So if that side is 5, then I can add up the 3 sides of the triangle right here, here, and here. So adding those up, I'll have 24 centimeters. Next problem, looking for the perimeter here. I will mark up my diagram. I'm looking for this x distance right there to find the perimeter, and also this distance here, but I know that that's 4.1. So if I drop down the 5, then I can use Pythagorean theorem to get the x. So that'll give me 5 squared plus 6.9 squared is equal to x squared. So solving that, I get that x squared is equal to 72.6. So square rooting x is equal to 8.5. So finding the perimeter, when I add all the distances around the outer edges, I find that that perimeter equals 28.6 centimeters. Next problem, finding the perimeter of this, I'm going to think of this as the straight section and the curved section. So if I find the curved section first, that curved circumference, the formula for circumference of a formula is pi times diameter, where the diameter is equal to 10. Okay, so if the whole circumference is equal to 10 pi, but then I have half of the circle, so the curved section will be 5 pi, whereas the straight section is 10. So altogether, the perimeter is 5 pi plus 10. In the next problem, we need the area, so we need the height for area to be base times height. Okay, so I could see that I need SOHCAHTOA to find that height. So labeling the sides. So x is my opposite, 12 is my adjacent, so I'm using tangent. So tangent of 70 degrees is equal to x over 12. So cross multiplying, x equals approximately 33 centimeters. So if x is 33 centimeters, then the area, 12 times 33, that whole area is going to be approximately 395.6 square centimeters. In the next problem, area of the parallelogram is base times height, where the base is this 9 and the height we don't know, so that's x. But we could figure out that height because, again, we have that 3, 4, 5 triangle. So that height is going to be 4, meaning that the area will be base times height. So 9 times 4 is 36 square centimeters. The key here is the base and the height have to be perpendicular, have to have that right angle. In this problem, the area of the rectangle is base times height. But the problem is on the grid paper where we have diagonals. So one thing I can do is draw in these right triangles to figure out the dimensions. So if that first dimension is x, then I can count spaces here. So this is 1, 2, 3, 4, and this is 1, 2. So applying the Pythagorean theorem, that x will be 2 squared plus 4 squared is equal to x squared. So x is going to equal the square root of 20. So that's that x dimension is the square root of 20. Then when we look for the other dimension, we could draw in another right triangle right there. So that triangle is 2 spaces by 1 space. So 2 squared plus 1 squared is equal to that y squared. So y is the square root of 5. So if the area is the base times the height, then it's going to be square root of 5 times the square root of 20, which, since they're both under radicals, we can multiply them together, and that equals radical 100, where the square root of 100 equals 10. So the area is 10 units squared. In this problem, we're finding the area of the triangle. We could find the dimensions using SOHCAHTOA, but it'd be faster to use the 30, 60, 90 triangle. So our long is 8, which means that our short is half of that. That's 4, and our medium is 4 radical 3. So that means area of the triangle is 1/2 base times height. So it's 1/2 times 4 radical 3 times 4. Okay, so then multiplying the whole integers together. Okay, so we have half of 4 is 2. 2 times 4 is 8. So we have 8 radical 3. And that's in square centimeters. In this problem, finding the area of this equilateral triangle. So if I mark it up, we need the height. So our base is that 10. Our formula is area is 1/2 base times height. Okay, so marking it up further. Okay, so an equilateral triangle has that 60 degree. So since we're splitting it, we have a 30, 60, 90 triangle, and that section here is 5. So that's our short distance, meaning that our height would be 5 radical 3. So for our dimensions, we have area is 1/2 times the whole base, which is 10, times the height, which is 5 radical 3. So multiplying that together, half of 10 is 5. 5 times 5 is 25. So 25 radical 3, and that's in square centimeters. In this problem, area equals 1/2 base times height. I always start writing down the formula. Okay, so marking it up. Let's see, I notice I have that right, that 45, 45, 90 triangle right there. So if the hypotenuse is 5 radical 2, then the sides would be 5. And this 5, that vertical 5 is the height. So that's my height, and here's my base. So finding the area of the triangle is going to equal 1/2. The base is 9, and the height is 5. So doing that calculation, we have 22.5 square centimeters. In this problem, we're finding the area of the trapezoid, so I'll start off writing down the formula. Area is 1/2 height times b1 plus b2. Then I'll mark up my diagram and see what dimensions I don't have. It looks like I have the b1 and the b2, but I don't have that height, so that's what I'm looking for. So now when I look at it, I see I have that 30, 60, 90 triangle where the hypotenuse is 12. So that means the short side would have to be half of that, so the height is 6. So plugging things in, 1/2. The height is 6. 5 plus 15. And doing that calculation, it equals 60 square centimeters. Again here, area of the trapezoid. Okay, so marking up the diagram, it looks like here I have that height. This is a sideways trapezoid. I have that B1, but I do not have the B2. So there's the B2. So that's what I'm looking for. Okay, so figuring out that, I'll mark up the diagram. If I draw a line there, so that's 8 right there. This 5 drops over. And then I could recognize that in that right triangle there, I have a 6, 8, 10 triangle. So a 3, 4, 5 times 2 is 6, 8, 10. So that dimension is 6, or I could get that with the Pythagorean theorem, meaning that the whole side there is 11. Okay, so plugging things into the formula, half times height, here it's sideways, so the height's 8, and B1 is 5, plus B2 is 11. So doing that calculation, it equals 64 square centimeters. This problem, writing down my formula. Okay, then marking it up. I know that dimension is also 4. So I have my B1, B2, and height. A height of 4, B1 is 4, and B2 is 11. So multiplying that out, 2 times 15 is 30 square centimeters. This problem, finding the area of the white space in the circle if the radius is 5. So we're looking for the area of these sections right here. That's our goal. So to find that area, we can do the area of the whole circle, take away the square. Okay? And it says that the radius is 5. So that's 5 by 5. Where the area of a circle is pi r squared. Okay, so then if the radius is 5, it'll be 5 squared pi, which is equal to 25 pi. So the area of the circle is 25 pi. Now we have to figure out the area of the square. Okay, so if I continue to mark that up, if I look at this triangle right there, it's 5 by 5, so the hypotenuse has to be 5 radical 2, because I know this is 45, 45, 90 triangle. So if the sides are 5 radical 2, then this area is equal to 5 radical 2 multiplied by 5 radical 2, which is equal to 5 times 5 is 25, and radical 2 times radical 2 is 2, so it's 50. So altogether the area will be 25 pi, take away 50 centimeters. So that's the remaining section in there. In this problem, we want the area of the sector, which is the percent of the whole, where in this case the whole is pi r squared. So if the area of the whole, let's see, if the radius is 6, so pi r squared, so 6 squared pi, which equals 36 pi. Okay, and then the percent would be 135 compared to 360 multiplied by 36 pi. So multiplying those coefficients of pi together and simplifying, that is 27 over 2 pi. sometimes written 27 pi over 2. So 27 pi over 2 represents the area of the sector right there. That's a portion of the whole area of the circle. This problem says a goat named Billy is tied to the edge of the barn with a 16-foot leash. This is the top view of the barn, and Billy cannot go through the barn. What's the total grazing area for Billy the goat? Okay, so understanding this problem, Billy is tethered right at this point of the barn. So the question is, find the area of the space in which Billy can graze. So here, Billy is tethered at point B, and the space which he is able to move is this. So since the leash has a length of 16, that 16 is the radius of a circle. But the sections of the barn in which Billy cannot go would be the area of that triangle right there, and then also the area of that sector right here. So it's going to be the area of the circle, take away the area of the triangle and the area of the sector. Okay, so figuring that out, first we could find the area of the whole circle. So that full area is pi r squared. So that's equal to 16 squared pi, which equals 256 pi. So that's the full circle. Then we need the area of the triangle, which is base times, so 1/2 base times height. We know one of those dimensions is 8, the width of the barn. We need to find that x dimension of it. So we know that the hypotenuse is the length of the leash, which is 16. So applying Pythagorean theorem there to get that x distance would be 8 squared plus x squared equals 16 squared. So when I solve for x, I would get 13.8. But now that I'm looking at it, what else I know is that the sides are in a proportion of 1 to 2, 8 to 16. So that means that that this has to be 30 degrees right here. This has to be 60 degrees and 90 degrees in order for the short side to be 8 and for the hypotenuse to be 16. So then that x distance is going to be 8 radical 3. So that would be a little faster way of figuring out this problem. Okay, so then we could say that the area of the triangle, so the area of the triangle is going to equal 1/2 base times height. So that's 1/2 times 8 times the height of 8, which equals 32 radical 3. So the area of the triangle is 32 radical 3. And finally, for the area of the sector, so we have a right angle right there, so the angle in the sector is 30. So the area of the sector would be 30 compared to 360 of the whole circle, where the whole circle is that 256 pi. So that area will equal 64 over 3 pi. Okay, so altogether we're going to have, so the whole area in which Billy the goat can move is the circle, take away the triangle, and take away the sector. So that's the area of the circle is 256 pi. Take away the triangle, which is 32 radical 3, so minus 32 radical 3, and then minus the area of the sector, which is 64 over 3 pi. Our like terms there are 256 pi and 64 over 3 pi. So when I subtract the like terms on the calculator, I'll get 704 over 3 pi. Take away 32 radical 3 pi. 32. And that's a 32 right there, so 32 radical 3. So final answer, 704 pi over 3 minus 32 radical 3 for the area in which Billy the goat can graze. Again, this is a challenge problem. Have a good day, class.